Okay, let's go ahead and take a look at 1.3, properties of exponents. We've got 4 objectives, looking at natural number exponents. Number 2, integer exponents. That includes the negatives and 0 and stuff like that. And then we'll look at the properties. And number 3 is really where we want to really dive in and get an understanding of those properties so that we can utilize those to simplify our exponents. And then scientific notation, that should take you back a little bit to chemistry. And so you did a little bit there. So good review. Let's go ahead and jump in. Natural number exponents, the components of a power. So the whole thing is a power. So when we talk about a power, now a lot of times we'll say like 4 to the third power. So sometimes the exponent we call a power, which is fine, but the whole thing's actually a power. The number that's up in the upper right is called the exponent, and then the a in this case is the base. And so the base is really important. We want to keep in mind we'll be utilizing that concept of base when we get to exponentials and logarithms later in the year. Let's go ahead and look at evaluating powers. And so for the most part here, you should be fine. Really, order of operations is the only thing you may have some issues with here, and that's what we just finished talking about in 1.2. But 4 cubed, as long as you sort of look to expand that out as 4 times 4 times 4, you should end up being fine at 64 is your value. Now, this is where your order of operations comes in because the next example is -3 squared. So what I'm squaring is both the negative and the 3. And so what I will multiply by is -3 times -3, which is +9. Unlike the third one, which is properly read the opposite of 3 squared. So it's very different. And so here what we have is the opposite of whatever 3 times 3 is. And so what we get here is we get -9 because we end up doing something like that. So we end up squaring just the 3, not the negative in that problem. Looking at the bottom one, again, just be careful not to do the double negatives. Exponents come before multiplication. And so we want to do -2 squared, which is 4, and then do the opposite of 4, which is -4. And so as we work through that, that's what it would sort of look like. So evaluating powers with the natural exponents. Let's go to integer exponents. This is where we'll spend most of our energy. First type of sort of property or thing that we would want to get down is this idea of a 0 as an exponent. And so for any real number other than, where a can't equal 0, 0 to the 0 is undefined. It's in what they call an indeterminate form. And so we want to just be careful there. We won't encounter that, but just understand when we say like anything to the 0 power is 1, we're excluding 0 itself. So that's sort of a flashcard. If you look at the arrow here, that would be a great thing. It's just like, what do I need to know about a 0 exponent? Is that anything raised to the 0 power is simply 1. Doesn't mean everything is 1. So we want to be very careful, and we'll see that in a second example. But in this case, I see a 0 exponent. So the question is, what has the 0 exponent? And for this example, this entire thing has. So this entire value to the 0 power just becomes 1. Right? Looking at this one next to it is not -3 to the 0 power. That would be something like this. So this is where that 1.2 comes into play. These are two different problems. So when we look at the one that we have up on the board, this is the opposite of 3 to the 0. So order of operations says what's 3 to the 0? 1. And then we want to know what the opposite of 1 is, which is -1. Okay, so be very careful. It's not always just the answer is going to be 1. It just depends on what has the 0 exponent. The second sort of property for integers that we'll look at is negative exponents. And so for any real number a other than 0, for any natural number n, what we have here is a to the negative whatever it may be n. In this case, for the example, I put 1. But if we have a to the negative n, that is equivalent to 1 over a to the positive n. So when we see negative exponents, we want to think about that means inverse, in this case, multiplicative inverse. So negative exponents means we going to flip the base with the negative exponent. So when we look at the first one and go back and review, we have 0 as an exponent. And so as a flashcard, I would say, okay, anything the 0 power is, and you would say 1. And it has to be whatever has a 0 exponent. Negative exponents. I'll say, oh, negative exponents, what do you do? And you say, flip it. And I'll say, what is it? And that pronoun it represents the base with the negative exponent. So again, just like the 0 exponent, not everything gets flipped, only the base that has the negative exponent. So if you look at the examples we have here, so if we look at the first one, I notice there's a negative exponent. I go, well, what has the negative exponent? T. So the only thing that flips is the t. Now, there's not really anything else for this problem anyways, but if let's say there's instead of 1 on top, there was 11 on top, well, then you would have a coefficient of 11 in front of t cubed because the 11 doesn't go anywhere. Okay, so that's what I mean by you've got to check and see what has the negative exponent. The second one will be a great example of that as well. We have 2x to the negative 3, and the question is what has the negative exponent? In this case, just the x. So the 2 doesn't do anything. It stays where it is, but the x gets flipped to the denominator. It means the inverse of x cubed is 1 over x cubed. Looking at the last one, if you have a fraction with a negative exponent, what we can do is we can say, oh, we have a negative exponent. What do? Flip it. What's the it? 1/2. So if we flip 1/2, that makes it 2 over 1 or 2. That allows us then to make my exponent positive. So flipping the base allows you to change the sign of an exponent. In this case, it ends up being 4. Okay. Now, this will hold even if the exponent is positive. So that's what we're going to, for advanced type of things. If I had, let's say, 1 over x cubed, I could rewrite this as, oh, I want to make let's say I wanted the base not to be in the denominator, I want it to be in the numerator, so I want to flip it. Well, then just simply change the sign of your exponent. And that allows you then to write something that is a positive exponent as a negative if you wanted to. Most of what we're doing in college algebra is going to end up being taking negative exponents and making them positive. Okay, moving along, here's the other properties. And hopefully they sound familiar to you from what you've done, let's say in Algebra 2, or even maybe a little bit in Algebra 1. And so we look and we have properties of exponents. First one's called multiplying powers. So when we multiply powers, the bases have to be the same for us to use this property. So if we're multiplying common bases, notice the base stays the same. When we multiply bases, the base stays the same. The only thing that changes is the exponent becomes the sum of the exponents. So when you multiply common bases, you add the exponents. Base stays the same. Dividing powers, fairly similar. It's going to be similar, but instead of adding the exponents, it'd be subtracting. So when you're dividing two powers and they have the same base, the base stays the same. So notice the base is the same all the way through. But what we're going to do for our new exponents, we're going to take the top exponent minus the bottom exponent. And so we end up subtracting exponents for this. Looking at the third one, power of a quotient. Okay, quotient means division. And so in this case, instead of dividing powers, what we have is a power on the outside of a division problem. So power of a quotient. And so a over b is my quotient, n is my exponent, so I have a power of a quotient. And what we want to do on this one is we simply share the exponent to every factor in the numerator and all the factors in the denominator. So a to the n over b to the n. Now, let's say it was a times c on the top. Then you'd have a to the n, c to the n on top. So if there are multiple factors, you want to share to everything. So we're not going to discriminate. We're going to share it to everything in the numerator, and we're going to share that exponent to everything in the denominator. However, be very careful. Never, ever take an exponent across the plus or minus signs. So help you God, you would owe me a soft snickerdoodle if that's the case. So what I mean by that is be very careful not to apply this property of sharing to something like this, where you want to try to take it across that plus or minus sign. That doesn't work. So this is not true. This would earn me some soft snickerdoodles from you. That is not true. Okay, so be very careful of that. So never, ever share an exponent across a plus or minus sign. So help you God, you would owe me soft snickerdoodles if you do. Okay, let's take a look at the power of a product. Very similar to the quotient. What we have those instead of a division problem, we have a multiplication problem inside. So the same rule though applies, is that we're going to share to everything inside of that product. So A times B, A gets it, B gets it. If there's a number in front of A, we would still share to that one if it's inside of our quantity. And then the last one's called power of a power, and that's when you have an exponent next to another exponent, and so A to the n to the m. In that case, what we do is we multiply those two. It really goes back to multiplying powers. If the exponents end up being the same up here, so let's say this is an n instead of an m, then what we have is a to the n like squared. Sorry about that. So it's a to the n squared. Well, what we do is we just can multiply those and we get a to the 2n, which is the same thing as adding n plus n, which is 2n. So it really connects and shrinks down our work. Rather than doing multiplying powers, we can just do power of power, which is multiplying exponents. So let's see some of these at work. And so the first one, what we notice here is that we have common bases and we're dividing. So this is where those properties come in. As you practice, as you go through the flashcards, you get used to them. When you see this, you go, oh, I'm dividing powers, so my base stays the same, but my exponent becomes the top minus the bottom. And so what you end up getting is 4 squared, which is 16. All right, so the common bases, that's the key. The base stays the same all the way through. Now let's go ahead and look at another example underneath this one. So you can see things are going to start getting a little bit tougher. I'm starting to pull a little bit more college algebra type of problems in there, and they do get pretty crazy. So just hang in there and do one thing at a time. There's not really a right or wrong way to start as long as you're doing proper math. And so in this case here, here's what I recognize. And you can do a lot of different things. We have a mess on the bottom. I know I have a negative exponent on the top, but I want to first off clean off the bottom a little bit. So first off, 2 cubed is 8. Now I'm going to go ahead and leave these things right there. Okay, so all I did was the 2 cubed, and I have this value to the negative 3. Now, what I have is now, this is, again, there's different things to do, but this is what I see. I have a negative exponent on the bottom. So right here, that negative 3. So I'm going to take this bubble and move it to the top. I do not change anything in the bubble. All I'm going to do is make that exponent positive. Then I notice also I have a negative exponent on top. I'm going to bring it down. So whenever you move quantities that have negative exponents, okay, that makes the negative exponent positive. But what students tend to look at is they see these negative exponents here and they're like, do we make those positive? I'm not dealing with those yet. What I see is simply a quantity. I don't care what's inside. I'm trying to make that negative exponent positive right now. So just sort of ignore what's inside of the bubble for right now. We'll deal with those negatives in just a moment. Okay, I haven't forgot about them. And you could deal with them early on as well. There's, again, you might see something different than me, and that's usually how I have the conversation with students, is when they're like, well, what do I do first? I usually ask, what do you see? And so they're like, well, I see a negative exponent. And I'm like, okay, we'll make that positive. Or I see multiplying powers or dividing powers. So it depends on what you see is how you would attack these problems. 2 to the 4th, I can go ahead. I'm going to do that right now. That's 16. So that worked out pretty nice. So that's going to be 16. Now I'm going to have power of a product. So I'm going to go ahead. I don't want to deal with those negative exponents yet. I want to go ahead and share that through. So I get 8 cubed, which is a fairly large number, over 16. And I have y to the negative 12, because when I share the exponent, I'm using power of a product, but I'm also using power of a power, which means I multiply those exponents because I have exponents next to each other. And I get y to the negative 21. So definitely the 2 with the negative exponents here and here, I can go ahead and flip down with the 16. 8 cubed, there's different ways to do that. If you want to just expand it out, it's a huge number. It's 512. Okay, but it's fine. That's what we can use a calculator for that. We'll probably need to reduce this a little bit, but definitely the x to the 12th can come down. That makes my exponent positive, and y to the 21st can come down, and that will make that exponent positive as well. Okay, so that's where we're at now. 512 and 16, that actually goes into it nicely. It's 32, And so I'll just go ahead and get rid of the 16. The 512s reduced down to 32. And so there's our final answer. So how do you know when you're done is when there are no parentheses, there are no negative exponents, and so everything's simplified like 8 cubed, and so you reduce your value down as well. So they're going to look for an answer such as what's in blue. I'm going to go ahead and erase that, so make sure to mark it down or pause if you need it. Let's go ahead and move to the next example here, and I'm going to keep working pretty quick. I'm going to actually reveal some of these other ones. That way it allows you to sort of work at your own pace, and you can see the different types of problems that you might encounter through Hawks. So let's go ahead. We've got this one done and we've got this one done. Let's go back to this one. Now we go back to sort of one that's fairly basic. You can do this two different ways. We're either dividing power, so you can subtract the exponents. That'd be perfectly fine. A lot of students see the negative exponents and they end up moving the m to the 7th and the m cubed and flip those two, which I think is perfectly fine. And then what you have is you have dividing power, so you subtract the exponents. Another way to look at dividing powers is to say, well, how many m's do I have on top? 7. How many m's do I have on the bottom? 3. Where do you have more of them at? Top. How many more? 4. Now, how you did that, hopefully, is almost through cancellation, where you're canceling 3 of those 7, and you're left with 4. So that would be perfectly okay. It's using the property in a different way, but that's be our answer for the third one. Take a look one right below that, and then we'll look at the other two. The one right below that one right here, you can see we have some x's on top and bottom. We have w's on top and bottom. We have negatives. So it depends, I guess, on what you see. I'm going to take care of those negative exponents maybe first. And so what I'm going to have is at my xw that was already down there, but then I move y to the 9th and w to the 4th down there with it. Now I can look to combine or simplify. And so here I can definitely cancel this 1x with one of those 7. That leaves me with 6. I like doing the canceling stuff. On the bottom, there's nothing for the y's. The y's are already finished and simplified, so y to the 9th is what we get there. And then the w's, notice we're multiplying common bases. The exponent of this w is 1. So when you multiply powers, you add exponents. Base stays the same. And so what we're going to end up getting in this case is w to the 5th power. And so again, that's a 9 right here. And there's our answer. Okay, I'm going to delete those and we'll look at the last two. They get a little bit tougher. That's why I wanted to clear the screen here for us. Looking at this one, and again, we want to be very careful. We have a negative exponent, but we have a minus sign. So I can't just take this and share it across, because that is a completely illegal move. Dang your hide, you owe me soft snickerdoodles. We can't do that. We've got to make sure that we do this a little different. So I'm not going to deal with the negative exponent right now. What I'm actually going to do is power of a product. I'm going to share this. And so I have, in this case, 4x to the 7th. And when I share this, 2 cubed, now don't multiply 2 times 3. It's 2 cubed. It's an exponent, is 8. And then when I share it to the y, now the 2 and the 3 is what I multiply, because those are both exponents. That's called power of a power. So we get something that looks like this. Now I want to deal with the negative exponent. Please do not take an exponent across a plus or minus sign, whether it's negative or positive. Don't do that. So what we want to do is simply flip that bubble. And so that bubble is going to go to the denominator. My exponent becomes positive, so don't really need the 1 out there. You really don't even need the bubble, to be honest with you. But I'll put it there. It's not wrong putting it. And so we've got 8y to the 6th. And so there we go. What's in black is our simplified expression. So it looks really complicated, but not a lot there. Looking at the last one here, I'm going to erase that. Looking at this last one at the bottom, again, you can do a few different things. I think what I'm going to do is I'm going to share the -1 first. Then I'm going to clean up the inside, and then I'm going to take care of this guy. So here we go. Let's go ahead, and we've got 3 to the -1. And then I've got x to the -1y. And I'm going to multiply that once I share that -1, and I get -2 because of multiplying those exponents, and y to the -1. Now I still got that -3 out there, so I haven't forgotten about it, but I'm just dealing with the inside right now. Now what I have is, let's combine my x's and my y's. Oops, yeah, 3 to the -1 still. Now, when I multiply common bases, I'm multiplying common bases, you add exponents. So I should get -3 here. And then when I multiply ooh, this is interesting. Look at what happens to the y's. You got 1 and -1, they go away. You get y to the 0. Well, anything to 0 power is 1. So in other words, what we have is the y sort of just vanishes because of that. Yeah, that's nice. Now I'm going to bring back in that -3. And you can either start flipping some things. You can do a lot of flipping. I'm probably just going to share it personally. I mean, I'm going to share this through, and that allows me to multiply those exponents. So my base stays the same, but I get +3 now. Base stays the same, but I get +9, and I'm really close to actually the answer. I just got to finish that off right there, and there we go. So that is one way of solving that. It's not necessarily the only way, but that is a way. Okay, let's keep moving. Topic 4, last objective, is scientific notation. And hopefully this is a good review for what you did, let's say in chemistry your junior year, but it's been a little while, so let's review it a little bit. So first off, what's the proper form for scientific notation? Well, again, we use scientific notations to allow us to write very large or very small numbers. That's why in science they use them for things that are in space that are huge, or if you're talking about micros and things that are extremely small and atoms and things like that. We want to be able to manipulate that information in a way to where we're not writing, 50 numbers or zeros and things like that. So we use scientific notation to allow us to do that. So to be in proper form, what we have is we're going to have a base A, and that base is technically the absolute value of the base. So the base can be negative, okay? So A could be negative. You can have -4. That's perfectly fine. But what I'm saying is the magnitude of A, whatever that A is, must be between 1 and 10, including 1, but not including 10. So it can't be a 2-digit number. If it is, we've got to we're not in proper form yet, and we've got to manipulate it so it is. Then what we have is times. That's what the x is times 10 to some power. If n is positive, the number is large in magnitude. That makes sense. And if if n is negative, that means technically we're dividing because it flips the 10 underneath. And so that decreases our value of our magnitude. And so we have this idea of moving the decimals to the right or to the left. And so if I give you a scientific notation, let's say 4 times 10 to the 5th, okay, something like that. The decimal currently is right there with our base A. And so if the exponent is positive, I think what you learned in science class is that we would move it to the right when it's positive 5 spots. And so you would have something like this. There's 1, 2, 3, 4, 5. So there's my new decimal. And then you would fill in those spots with zeros. And so we end up getting 400,000 is what that is, okay? If it's negative, you would move to the left, the same number, and fill in the spots with 0 as well. So I think that should be a review. But I also want to take a look at something down here at the bottom that will help as well, because sometimes we get things mixed up for something like, let's say it was something like 14 is what we got. That is not in scientific notation because 14 is not between 1 and 10. So what I want to do is take the decimal, which is here, and move it this way. And so when we move it that way, what students have a tendency to do is go, oh, we move it to the left, so my value needs to shrink. But here, moving to the left doesn't shrink things. And so there's a different, once it's in scientific notation, and if you leave it in scientific notation, we need to not look at it as right and left with positives and negatives. What we want to do is think about this. I started with it being 14, and when I moved the decimal over, I made my value shrink or go down. So I made it smaller. When you make the value smaller, then that means to counteract this, I need to make sure to make my exponent larger. So if I moved over 1, so I shrunk my position by 1, I'm going to increase my exponent by 1. And so this is the same thing as 10 to the 6th. Now you can verify this. Take this and move it 6 times to the right. Take what we started with and move it 5 times to the right, and they should be the exact same number. So if your value goes down, your exponent goes up. Let's say it was this. Now it's not in scientific notation. I've got to move my decimal right here, so it becomes 1.4. But the question is what happens to my exponent? Is it 6 or is it a 4? Well, notice what I've done is I've went from 0.14 to 1.4. So I increased its value by one placeholder. So I need to make sure to increase my exponent by, or excuse me, decrease my exponent. So I got to do the opposite. So if that one goes up, this one goes down by 1. Okay. So that's really, I like that. I think it helps students out once you get the hang of it. But if you're in scientific notation, don't think right or left. You want to be thinking about, oh, if I increase, then I decrease the exponent, or if I decrease the value, then I need to increase the exponent. Okay. How are we going to use it? Is just, here's the college algebra, is that we're going to be using our properties to do it. But I want to make sure you knew scientific notation before you do the properties. So we have this times this. Now it looks like a FOIL, but it's not, because this is not a plus or minus sign. So if I rewrote it, it makes a lot more sense. Now you do not have to rewrite this, but I want to show you this because once you see it, it'll make a much more sense to you, because all we're doing is multiplying 4 things. And multiplication is commutative. And if you remember when we talked commutative property back in 1.2, what we said is the order doesn't matter. So what I'm going to do is I'm going to order the two numerical values together. So I'm going to do 2.3 times 2. I'm going to put those two together. Then I'm going to put my x. Okay, so it's like multiplication. And then I'm going to put the two bases that are common next to each other. So it looks like this. Now, why I do that is I can go ahead and multiply these two, 4.6, and then I've got my times. And then whenever you have common bases and you're multiplying, what do you do with the exponents? That's one of our properties. You add the exponents. And so we end up getting 4.6 times 10 to the 25th is our answer. Okay, for something like that. So using our properties allows us to do operations of scientific notation. Okay, let's look at another one and sort of see what's going on. Similar idea, but this time I'm going to go a little faster, and that way we can see what happens with this. So looking at this problem right here, what we have is we have 6. So it's really like the first one, but it's just more is all it is. And so let me show you, instead of just rearranging it, you can leave it as it is and just multiply the 6, the 5, and the 5. And if you have, 5 times 5 is 25. You have 6 quarters. That's how I look at it a little bit. It's $1.50. So what we have is 150 if we do it that way. And then when I multiply the tens, the bases together, we simply add the exponents. So 21 plus negative 19 is 2, plus 4 is 6. Now, hopefully what you notice is this is not the correct answer because it's not in scientific notation. So this is what we talked about a little bit before. So 150, I got to go 1, 2 to get that into the correct spot. So I get 1.5 times 10. Now the question is, I move this 2, does it go to 8 or 4? This one shrunk by 2. So I went down 2 placeholders. So this means this needs to go up 2 to keep it balanced. So I'm in scientific notation or something similar scientific notation and staying there. That's how we want to look at this. You can always check yourself by using a calculator. That's the beautiful thing. Looking at the very last example here is one with division and multiplication, and you can do this a few different ways. What I notice is this. Sometimes, like, you can see the 4 and the 8. You can simplify those. Sometimes it's easier just to multiply and then divide. I think that's what I'm going to do, is I'm going to go ahead and multiply and then do the division. So my numerator stays the same. My denominator ends up being 40 times 10 to the first. When you multiply powers, you add exponents. Now, that's not in scientific notation, but I'm not going to worry about it right now because I've got to figure all this out anyways. Now, remember, in scientific notation, we want to leave our answer as a decimal. So when we look at 4 over 40, Let's go ahead and just simplify that. 4 over 40. That ends up being 1/10. And 1/10 as a decimal is 0.1. So 4 divided by 40, you put that in calculator, or if you do it by hand, you get 0.1. Now, here, notice that I have 10 to the negative 6 and 10 to the first. So when I divide powers, I subtract exponents. And so that's our property there. So I'm going to get 0.1 times 10 to the negative 7. Now, I'm not done. That's not in scientific notation. So what we do is we move this over 1. So this went up in value by 1. So this needs to go down in value by 1. So we have 1 times 10 to the negative 8, or 10 to the negative 8. But that's in scientific notation with the 1 in front. Okay. And that ends up being 1.3 properties of exponents. So just really focus in on those properties, make flashcards, go over and over and over them, and with a lot of practice, you'll end up getting the hang of it, and this will help us with future college algebra topics.